Hi, my name is Valery Zeridyuk. In this demo, I'm going to demonstrate you the new ModelBus service. This service aims at improvement of the collaborative work in distributed software development processes. In contrast to the previous collaborative approach, the new approach covers different model domains. Thus, the engineers are able to synchronize in real time models of different type or domain. Okay, let's get down to business. The scenario of the demo is the following. Two engineers are working at the same time and on the same project. Their task is to create a model that describes the anti-lock braking system ABS. The engineers use EAST-ADL2 as modeling language. The first engineer is a software engineer and is working on the functional model. Let's call it software model. The second engineer is the hardware engineer and is responsible for the hardware model. The software engineer is on the left-hand side of our scenario picture, and the hardware engineer is on the right-hand side of our scenario picture. The arrows give you a first idea about the data flow in our scenario. Looking at the abstraction levels defined by EAST-ADL2, the engineers are at the design level. This picture shows you an overview of all abstraction levels, and here is the design level. Okay, let's take a look at the development environment of both engineers. On the right side is the IDE of the software engineer with the software model. This model describes the transformation behavior of functions as well as data flow between them. For example, this chain processes the signal coming from the pedal and puts it through to the wheels. On the left side is the IDE of the hardware engineer with the hardware model. This shape describes the system's hardware infrastructure. There are only a few control units. This model is very simple and requires some more details. Well, both model types are interrelated. That means the software model could contain hardware information and vice versa. Both model types contribute to overall system description and are usually developed concurrently. And it might be necessary to synchronize both models. Well, assume our both models are incomplete. The software and the hardware model don't have any information about the sensor or actuator at the moment. Well, how engineers can use the new collaborative service to overcome this knowledge gap? Okay, remember this picture. And assume that the ModelBus server is running in the background. The new collaborative service has been registered and is waiting for inputs from the graphical editors. The software engineer is aware of possible hardware infrastructure and adds some information to his software model. He adds a hardware function type that describes a transfer function and therefore a possible sensor on the hardware layer. To put it differently, an element of type hardware function type on the software model can be mapped to the element of type sensor on the hardware model. Let's do it. Well, what's happened? The service has noticed the creation of the new element on the software model and used the predefined relational QVT rule set to perform the transformation of model elements in real time. The output is the model element of type sensor on the hardware layer. Look at it right here. That is, the first engineer has managed to propagate some useful information about the sensor in the model. And the overall data flow is given in this picture. Now, both engineers can use previously created information to refine their models. For example, let's change a type of some elements using previously created elements. Okay, let's change a type of pedal sensor. And on the hardware model, let's also change the type using previously created sensor. Well, a collaborative service is like a third software engineer in the middle, and it gives a hand with modeling issues. The only thing he needs is the relational QVT rule set. The collaborative service is also trace-based, that is, only changes are shared between the models. For example, if a software engineer changes the name in his model, only a name change is propagated. Let's try it out in our example. Okay, let's change the name of this type. From 1 to, let's say, 0. As you can see, the initial name change has influenced a chain of further changes. Here, here, and also on this elements. Everywhere is instead of 1, 0. Well, this approach also works bidirectional. Therefore, actions of the second engineer are also processed. Let's add more elements on the hardware layer. Let's add a sensor. Let's also add an actuator. As you can see, some elements have been added to the software model. Well, now we are done. Finally, I would like to mention that this approach is applicable to all GMF-based graphical editors, and the main challenge using this approach is to define a relational QVT rule set. Thank you for your interest, and bye-bye!